Have you ever looked up at the night sky and wondered what's happening way out there? Well, NASA has a special telescope called the Neil Gehrels Swift Observatory that does just that. It looks for some of the biggest explosions in the universe. But right now, Swift itself is in a bit of trouble. It's falling. Not fast, like a rock, but very, very slowly. It is getting closer and closer to Earth. If we don't do something, it could fall out of the sky and burn up in our atmosphere. That would be a huge loss for science, everyone. So NASA has a plan. A very cool plan. They are spending $30 million to save it. This isn't just about one telescope, it's about an idea. The idea is that we can fix things in space. For a long time, when a satellite stopped working or ran out of fuel, that was it. It became space junk. But what if we could go up there and give it a push, or refuel it, or even repair it? That's what this mission is all about. It's a test to see if we can help a satellite that was never, ever designed to be helped. It's like trying to fix a car on the highway while it's still moving, and the car wasn't built to have its hood opened. It's a big challenge, but the payoff could be enormous for how we explore space. The mission to save Swift is a big deal. A company called Katalyst Space Technologies is building a special robot spacecraft. This robot will be small, but very smart. Its job is to fly up to Swift, grab onto it very gently, and then give it a push. This will move Swift into a higher, safer orbit where it can keep working for many more years. Think about that. We are sending a robot to meet another robot hundreds of miles above our heads. This push will add years to Swift's life, allowing it to continue its amazing work of watching the cosmos for us all. It's a rescue mission in the vastness of space. Why spend so much money on an old telescope? Swift was launched way back in 2004. Well, it's because Swift is still incredibly important. It's a one-of-a-kind cosmic alarm system. When something big happens out in deep space, like a star exploding, Swift sees it first. It quickly sends an alert down to Earth so that other, bigger telescopes can turn and look at the event right away. Without Swift, we might miss the very beginning of these amazing cosmic fireworks. Saving it means we keep our eyes on the universe. It's a small price to pay to keep our window to the cosmos wide open. So, what does the Swift telescope actually do that makes it so special? Imagine you have a guard dog that is always watching for something unusual. Swift is like that, but for the entire universe. Its main job is to spot gamma-ray bursts. These are the most powerful explosions we know of. They can happen when a massive star, much bigger than our sun, runs out of fuel and collapses into a black hole. For a few brief moments, this explosion can outshine entire galaxies. It's an incredible, universe-changing event, and Swift is built to find them, fast. When Swift detects a flash of high-energy gamma rays, it does something amazing. Within seconds, it automatically pivots to get a better look with its other two telescopes, which see in X-ray and ultraviolet light. It's like hearing a loud noise and instantly turning your head to see what it was. But Swift does more than just look. It figures out the exact location of the burst in the sky. Then, it beams that information down to scientists on Earth. This all happens in less than a minute. That's faster than you can make a sandwich. This speed is what makes Swift so incredibly valuable. This rapid alert system is a game changer for astronomy. Once scientists get the coordinates from Swift, they can point other powerful telescopes at the location. This includes huge observatories on the ground and even the Hubble Space Telescope. They can study the afterglow of the explosion. It's like detectives arriving at a crime scene. By studying this fading light, they can learn about the star that exploded, the galaxy it lived in, and even the nature of black holes. Swift is the first responder, letting everyone else know where to look before the evidence disappears. It's teamwork, on a cosmic scale. But Swift doesn't just hunt for gamma-ray bursts. Over the years, it has become a jack-of-all-trades telescope. It has studied comets in our own solar system. It has watched stars get torn apart by supermassive black holes. It helped us understand where heavy elements like gold and platinum come from. By observing all sorts of things that go boom in the night, Swift has contributed to thousands of scientific papers. Losing it would leave a huge gap in our ability to monitor the high-energy universe. That's why keeping our Cosmic Watchdog on duty is so important. Why is Swift falling in the first place? It has to do with where it lives. Swift is in what we call low Earth orbit, or LEO. This is a region just a few hundred miles above our heads. It's where the International Space Station flies, and where thousands of other satellites live. Being in LEO is great for many missions because it's relatively easy to get to. But there's a catch. Even that high up, there is still a tiny bit of air. It's not much, but it's enough to cause problems. It creates a small amount of friction, or drag. Think about sticking your hand out of the window of a moving car. You can feel the air pushing against it. Now, imagine a satellite moving at over 17,000 miles per hour. Even the thinnest wisp of air creates a constant gentle push. This atmospheric drag, works like a brake. It slowly robs the satellite of its speed. As the satellite slows down, its orbit gets a little lower. As it gets lower, the air gets a tiny bit thicker. This thicker air creates even more drag, which slows it down more. It's a slow, downward spiral that is happening to every satellite in LEO. Now, our sun can make this problem even worse. The sun goes through cycles of activity, about every 11 years. When the sun is very active, it sends out more energy and particles, creating what we call solar storms. This extra energy heats up Earth's upper atmosphere. When the atmosphere gets hotter, it expands, just like a balloon. This means the thin air that causes drag reaches up to higher altitudes. So, during active solar periods, satellites in LEO experience much more drag than usual. They fall faster. We are in an active solar period right now, which is why Swift's situation has become so urgent. Many satellites, like the International Space Station, have their own engines. They can fire their thrusters every so often to give themselves a boost and stay in a stable orbit. But Swift doesn't have any engines. It was launched with a certain amount of energy, and it has been slowly losing that energy to drag ever since. Without a push, it's predicted that Swift will re-enter the atmosphere by late 2026. This mission is a race against time and the sun's activity to give Swift the boost it needs to keep flying high and doing science for all of us. So, how exactly do you push a delicate spinning telescope in space? Very carefully. The plan is to use a small robotic spacecraft, a servicer, built by Katalyst Space Technologies. This servicer, named Link, will be launched into orbit and will slowly approach the Swift telescope. This is the tricky part. Swift was not designed to be grabbed, docked with, or refueled. It has no special handles or docking ports. It's like trying to grab a smooth, spinning bottle. The team had to get creative. They found a solution by looking at how Swift was handled on the ground before its launch. The robot will use a special grappling mechanism. It will gently lock onto small metal rings on the telescope that were used to move it around in the factory. This is a non-invasive approach. The robot won't have to cut or weld anything. It will just hold on tight. Once Link has a firm grip, it will use its own small engines to give Swift a gentle, steady push. This will raise Swift's orbit by about 30 miles. That doesn't sound like much, but at that altitude, the atmospheric drag is much weaker. This small boost will be enough to keep Swift safely in orbit for another decade or more. This mission is exciting because it's a pioneering step for the future of spaceflight. If this rescue works, it proves that we can service satellites that were never meant to be serviced. Think of all the valuable but aging satellites currently in orbit. Telescopes, weather satellites, and communication satellites. This technology could one day extend their lives, saving billions of dollars and preventing them from becoming dangerous space junk. It opens the door to a new era of sustainability in space, where we repair and reuse our assets instead of just abandoning them. It's a greener, more responsible way to operate in orbit. Ultimately, saving Swift is about more than just one telescope. It's about keeping space safe and useful for everyone. As more and more satellites are launched, the problem of orbital debris, or space junk, gets worse. Every old satellite left to tumble in orbit is a potential hazard. By developing the ability to move satellites, we can also develop the ability to safely deorbit them at the end of their lives, guiding them to burn up harmlessly over the ocean. This mission is a test of that technology. It's a bold, forward-thinking plan that helps science today and makes space safer for generations to come. And that is pretty cool.